In 1977, the Voyager 1 space probe was launched to study the outer solar system.
Roll program is in on time. Vehicle response is normal.
Breaking. Voyager 1 returns with impossible data from the edge. After months of radio silence, humanity's farthest spacecraft Voyager 1 has suddenly resumed communication. But what it's transmitting has left the scientific community in shock. For nearly half a century, this pioneering explorer ventured where nothing human-made had gone before, only to fall silent. Until now, the signals have returned, crisp and intelligible, but the information they carry defies explanation. One renowned physicist with a Nobel Prize to their name has issued an alarming statement. This fundamentally alters our understanding. We're potentially observing something that shouldn't exist within our current framework. What has Voyager 1 discovered at the boundary of interstellar space? And why are certain experts suggesting this could be the key to unlocking the cosmos' greatest enigma? Join us as we explore what might be the first communication from the unknown, a transmission that could rewrite astronomy textbooks and challenge our place in the universe. The implications stretch beyond mere scientific curiosity. If Voyager has indeed encountered something unprecedented, we may be witnessing the first chapter in humanity's greatest discovery. The question isn't just what Voyager found, it's whether what it found has been watching us all along. The Grand Tour, a once-in-2 centuries opportunity. Launched in 1977, Voyager 1 wasn't expected to survive beyond a decade at most. Instead, it has endured 45 years in the most inhospitable environment imaginable. Its journey took it beyond Jupiter, past Saturn, before gravitational forces propelled it outward into the depths of space, leaving our planetary neighborhood behind. What enabled this remarkable mission wasn't merely engineering excellence, but an astronomical alignment occurring just once every 176 years. The planets positioned themselves perfectly, allowing engineers to catapult Voyager from one celestial body to another using gravitational assistance, conserving fuel while achieving unprecedented velocity and distance. This celestial choreography, dubbed the Grand Tour, proved extraordinarily successful. Today, Voyager 1 travels more than 14 billion miles from Earth, venturing where no human-created signal had reached until Voyager began transmitting back information that challenges scientific understanding. The impossible transmission, breaking the laws of physics. Following a period of corrupted transmissions, something unexpected occurred. Voyager 1 resumed sending interpretable data. However, this information wasn't merely unusual, it was theoretically impossible. Scientists detected anomalous plasma behavior, magnetic field distortions, and unexpected particle density surges. Most perplexingly, these measurements contradict everything we've previously recorded about interstellar space. As one physicist stated, the spacecraft appears to have crossed beyond the solar system and into something entirely different. The cosmic ray orientations and magnetic field alignments suggest Voyager 1 has entered a zone of space unlike anything in our models. It's as though the fundamental principles of reality are transforming around the spacecraft. The computer on board Voyager, a machine with less processing power than a modern calculator, is nevertheless recording phenomena that our most advanced theoretical models cannot explain. The plasma density readings alone have stunned experts, showing concentrations hundreds of times greater than expected in what should be nearly empty space. Meanwhile, the magnetic field measurements reveal structures too organized, too symmetrical to be the product of random cosmic processes. The boundary beyond the boundary. Entering unknown territory. When Voyager 1 traversed the heliosphere, the outer limit of our sun's influence, scientists believed it would encounter relatively empty interstellar space. The new data reveals this region is anything but vacant. The probe detects turbulence, plasma fluctuations, and charged particle storms with no identifiable source. More concerning are gravitational irregularities causing the spacecraft to drift unexpectedly, influenced by forces our instruments cannot identify. This movement isn't attributable to stellar gravity or asteroid collisions. What's causing this subtle yet measurable displacement? Some researchers now propose Voyager has entered a transitional region, a threshold space between the known universe and something beyond where established physics may no longer fully apply. This transitional zone wasn't predicted by any astronomical model. For decades, scientists believed the boundary between our solar system and interstellar space was relatively simple. The heliosphere ends, and true interstellar space begins. Voyager has revealed a far more complex reality, a gradient of increasingly strange phenomena that suggests our solar system doesn't simply end, but rather transforms gradually into something else entirely. The Nobel laureate's warning, confronting new cosmic realities. For years, most scientists maintained cautious perspectives, methodically studying the data. Now, a distinguished Nobel Prize-winning physicist has made an unprecedented statement. Voyager 1 is detecting patterns incompatible with our current universal models. We may be witnessing evidence of another spatial domain or structure. While stopping short of explicitly mentioning additional dimensions, many are questioning whether Voyager 1 might be approaching the periphery of something entirely different, a multiverse, the boundary of simulated reality, or perhaps the outskirts of a cosmic construction beyond our comprehension. The physicist, whose groundbreaking work on quantum field theory earned them science's highest honor, has staked their reputation on the significance of Voyager's findings. Throughout history, our greatest leaps in understanding have come when observations forced us to abandon comfortable theories, they noted in a recent interview. What Voyager is showing us suggests we've been viewing the universe through an incomplete framework. The mathematics simply don't allow for what we're seeing under our current models. This statement has divided the scientific community. Traditionalists argue for more conservative interpretations. Perhaps our models of interstellar medium are simply incorrect, or Voyager's aging instruments are producing faulty readings. But a growing faction of theoretical physicists are embracing more radical possibilities, dusting off long-dismissed models like modified gravity theories, steady-state cosmology alternatives, and even speculative frameworks involving higher dimensional spaces that might intersect with our observable universe. The cosmic pulse is something responding to Voyager. Among the latest transmissions, researchers discovered a rhythmic fluctuation, a pulse emanating from a region Voyager 1 recently traversed. This signal isn't random background noise. It's structured, timed, and repetitive, matching no known stellar phenomenon. Initially dismissed as equipment malfunction or interference, the pattern remained consistent. More unsettling was the realization that the pulse appeared reactive during certain intervals, intensifying slightly following each of Voyager's data bursts, almost as if something was monitoring and responding to our distant explorer. Signal analysis experts from multiple space agencies have independently confirmed the pulse's existence. Using advanced filtering algorithms designed to separate genuine signals from background noise, they've identified a waveform with precisely timed intervals that subtly shift in response to Voyager's transmission schedule. The probability of this being coincidental has been calculated at less than 1 in 10 billion. What makes this pulse truly extraordinary is its complexity. Unlike natural phenomena like pulsars or quasars, which produce relatively simple, consistent signals, this pulse contains internal structures, variations within variations, patterns nested within patterns. When analyzed through spectral decomposition, these patterns reveal mathematical relationships similar to those found in prime number sequences and Fibonacci ratios, the kind of ordered complexity typically associated with designed rather than natural systems. The hidden structure, patterns in the void. An engineer working to decode Voyager's recent transmissions made a remarkable observation. When visualizing magnetic field variations as a three-dimensional model across time, a distinct pattern emerged, not random interference, but a spiral framework repeating with near-perfect symmetry. Some theorize this could represent a gravitational lattice or cosmic grid beyond current scientific understanding. More radical interpretations suggest it might be the signature of an artificial structure far beyond our solar system, or perhaps even our universe. Whatever its nature, it has no precedent in astrophysics, yet Voyager 1 passed directly through it. The visualization technique that revealed this structure was itself a breakthrough. Using a novel approach that combined magnetic field readings with plasma density measurements across multiple timeframes, researchers created a four-dimensional model that revealed what had been hidden in plain sight. a geometric pattern too complex to detect in conventional two-dimensional analyses. This structure exhibits properties that defy conventional understanding of cosmic magnetic fields. Unlike the chaotic, turbulent patterns typically found in space, this formation maintains consistent symmetry over vast distances. Its spiral geometry follows mathematical principles similar to those found in certain quantum field equations, suggesting a connection to fundamental forces rather than localized phenomena. Most puzzling is the structure's scale. Initial estimates suggest it extends across a region at least several light-years in diameter, making it potentially one of the largest coherent structures ever detected. Yet despite its enormous size, it maintains precise geometric relationships throughout a level of organization that stretches credibility for natural formation. Quantum anomalies, existing in multiple places at once. Voyager 1's onboard systems have begun behaving erratically, but not in ways typical of aging technology. Its orientation sensors report conflicting positions simultaneously, as though the spacecraft exists in multiple coordinate spaces at once. Even more puzzling, its signal shows minor but measurable variations in transmission speed, suggesting passage through regions where space-time itself may be distorted. This isn't merely instrument deterioration. Some scientists now quietly propose that Voyager may have entered a zone of variable dimensional space, a concept previously confined to theoretical physics that may now have become observable reality. The positioning anomalies first appeared subtle discrepancies of just a few kilometers in Voyager's reported location. Engineers initially attributed these to expected degradation in the aging spacecraft systems. But as the discrepancies grew and followed recognizable patterns, it became clear something more profound was occurring. At times, Voyager's telemetry suggests it occupies slightly different positions simultaneously, positions that can vary by hundreds of kilometers, yet remain stable enough for consistent communications. What's particularly striking about these position anomalies is their correlation with other measurement irregularities. When Voyager reports these spatial discrepancies, it also detects unusual variations in the surrounding quantum vacuum energy fluctuations that mirror theoretical predictions for regions where space-time curvature becomes non-uniform. The transmission speed variations provide even more compelling evidence of spatial anomalies. Radio signals from Voyager occasionally arrive slightly earlier or later than relativistic calculations would predict, as if the signals are traveling through regions where the speed of light itself varies slightly. These variations follow patterns too consistent to be measurement errors, yet they contradict one of physics' most fundamental constants. Beyond the mission, the unintended discovery. When Voyager launched, its purpose was never to leave the solar system. Its primary mission involved observing the gas giants before drifting into oblivion. Yet 4 decades later, it's accomplishing something far more profound, revealing the true architecture of reality itself. What began as planetary exploration has evolved into a voyage into the unknown structure of the universe. Ironically, the spacecraft carrying humanity's message to the stars, the Golden Record, may be the first to receive a message in return. The mission extension that allowed Voyager to continue operating beyond its planned lifespan was itself a testament to human curiosity. When the spacecraft completed its primary planetary observations, engineers and scientists fought to maintain funding, arguing that the probe could provide unique insights into the outer solar system. No one anticipated it would eventually challenge our fundamental understanding of physics itself. Voyager's extended journey has been marked by a series of unexpected discoveries. It revealed the true boundary of our solar system's magnetic influence, detected the pressure of interstellar space against our heliosphere, and mapped the transition region where solar particles give way to galactic cosmic rays. Each of these findings expanded our understanding of our cosmic neighborhood. But these current anomalies represent something entirely different, not just new information about known phenomena, but evidence of phenomena that shouldn't exist according to our current understanding. It's as if Voyager was sent to map unexplored territory and instead discovered that the map itself might be wrong, that reality beyond our solar system operates according to principles we haven't yet grasped. The ambassador at the edge, redefining our place in the cosmos. Voyager 1 was never designed to travel this distance. launched with 1970s technology and less computing power than a modern digital watch. It was directed toward planets we thought we understood. Now, 45 years later, it transmits data forcing Nobel laureates to reconsider the fundamental nature of our universe. A pulse resembling a signal, patterns hidden in magnetic noise, spatial anomalies suggesting multiple realities, and a journey that increasingly resembles less an escape from our solar system, and more an encounter with something else, something ancient, beyond conventional physics, perhaps even observing us. The spacecraft's longevity itself defies expectations. Engineers designed Voyager with a 5-year primary mission in mind, building in redundancies and protective measures to ensure it could survive long enough to photograph Jupiter and Saturn. That this same hardware continues to function nearly half a century later, in conditions far more extreme than originally anticipated, speaks to both engineering excellence and extraordinary good fortune. As Voyager ventures further into uncharted territory, its significance transcends mere scientific investigation. It has become a philosophical probe, testing the boundaries not just of our solar system, but of our comprehension. The data it returns challenges us to reconsider fundamental questions. Is our understanding of physics complete? Are the laws we've discovered universal, or do they apply only within our cosmic neighborhood? Might there be aspects of reality we haven't detected because we've never ventured far enough from home? The final frontier. What happens when space ends? We must now consider. Is Voyager 1 still exploring space as we understand it, or is it revealing that space itself may have boundaries we never imagined? Has Voyager truly entered a new dimension, or are we witnessing the first indication that humanity was never alone in the cosmos? Stay connected for updates, because Voyager's next transmission could contain the message humanity has awaited since time immemorial, the answer to what truly exists beyond the known universe. The question of space's ultimate nature has haunted humanity since we first gazed skyward. Ancient philosophers debated whether the cosmos extended infinitely or possessed definite boundaries. Modern cosmologists have proposed various models: infinite expansion, eventual contraction, or membrane-like boundaries separating our universe from others. But these remained theoretical constructs, impossible to test directly until now. Voyager's journey forces us to confront the possibility that space itself may be more complex than we imagined. Perhaps it doesn't simply extend endlessly in all directions, but instead possesses structure, domains, or even transition zones where the fundamental properties of reality shift subtly. If the readings suggesting variable spatial coordinates prove accurate, we may need to reconsider whether position itself is as absolute as we've assumed. The implications stretch beyond academic curiosity. If space possesses boundaries or transition zones, it could fundamentally alter our understanding of cosmic evolution, the distribution of matter throughout the universe, and even the ultimate fate of our cosmos. The universe might not be a uniform expansion from a singular beginning, but rather a complex patchwork of domains with different properties and histories. More provocative still is the possibility that what Voyager has encountered represents intentional design rather than natural phenomena. The regular geometric patterns, the responsive pulse, the organized structure, these characteristics share more in common with engineered systems than with the chaotic processes we typically observe in nature. If true, we must ask, designed by whom and for what purpose?